In a previous class, we discussed about the field effect transistor. पिछली वाली क्लास में हमने देखा था field effect transistor क्या होता है, definition of the field effect transistor, then the classification of the field effect transistor and the characteristics of FET. तो पिछली वाली क्लास में हमने ये सारी चीज़ें कंप्लीट की थी, मींस FET हमने कंप्लीट किया था. So in this lecture, we will study about what is MOSFET, metal oxide semiconductor field effect transistor. इसके बारे में हम स्टडी करेंगे. Second is mode of operation. After this, we will move on the working principle of the MOSFET. Next is a types of MOSFET. After this, we will move on the output characteristics of metal oxide semiconductor field effect transistor. Next topic is MOSFET as a switch, means using the MOSFET as a switch. How can we use the MOSFET as a switch? So in this topic we will study. And finally the references of this presentation. So in this presentation we will learn all these topics one by one. So let's start with the topic introduction of MOSFET. So first question is that what is the full form of MOSFET? So the full form of MOSFET is metal oxide semiconductor field effect transistor. The MOSFET stand for metal oxide semiconductor field effect transistor. आप देख सकते हैं इसमें लिखा हुआ है full form. The transistor is a semiconductor device which is widely used for switching and amplifying electronic signals in the electronic devices. एक्चुअली BJT, MOSFET, FET, GFET इन सारी चीज़ों का यूज़ हम एज अ स्विचिंग और एज अ एम्पलीफायर की तरह करते हैं, जिससे कि हमें इलेक्ट्रॉनिक सिग्नल को जब एम्पलीफाई करना होता है तो हम इन डिवाइसेस का यूज़ करते हैं. ये सारे के सारे डिवाइसेस हम इलेक्ट्रॉनिक सर्किटरी में यूज़ करते हैं. The MOSFET is a core of integrated circuit, means in short IC, and it can be designed and fabricated in a single chip because of these very small size. The MOSFET is a 4-terminal device with the name is source represented by capital S, gate represented by capital G, drain represented by capital D, and body represented by capital B terminals. The body of the MOSFET is frequently connected to the source terminal, so making it a 3-terminal device like a field effect transistor. बॉडी जो टर्मिनल है उसका हम वो फ्रिक्वेंटली कनेक्टेड करते हैं टू द सोर्स टर्मिनल. सो हम बोल सकते हैं कि जो मॉसफेट होता है वो 3-टर्मिनल डिवाइस होता है, जस्ट लाइक एज अ FET, मीन्स फील्ड इफेक्ट ट्रांजिस्टर. फील्ड इफेक्ट ट्रांजिस्टर की ही तरह जो है वो मॉसफेट काम करता है, बस डिफरेंस ये है कि इसमें मेटल ऑक्साइड सेमीकंडक्टर हम मेटल ऑक्साइड जो है वो हम एक्स्ट्रा इसमें यूज़ करते हैं फॉर मेकिंग द मॉसफेट. सो इट्स नेम इज मेटल ऑक्साइड सेमीकंडक्टर फील्ड इफेक्ट ट्रांजिस्टर, इसीलिए इसको मॉसफेट बोलते हैं. The MOSFET is a very for the most common transistor and can be used in both analog and digital circuits. This is the diagram of the MOSFET. You can see the terminal. There is a 4-terminal. First one is a source, second one is a drain, third is a gate, and fourth one is called the body. So what is MOSFET? The MOSFET is a 4-terminal device. अभी हमने डिस्कस किया है 4 टर्मिनल होते हैं, सोर्स, गेट, ड्रेन और बॉडी, जिसमें बॉडी को हम बहुत फ्रिक्वेंटली कनेक्टेड जो रहता है वो सोर्स टर्मिनल से रहता है, इसलिए हम इसको बोलते हैं इट्स अ 3-टर्मिनल डिवाइस, जस्ट लाइक एज अ field effect transistor. MOSFETs operate the same as JFET, means junction field effect transistors, but have a gate terminal that is electrically isolated from the conductive channel. The IGFET or MOSFET is a voltage controlled FET. IGFET का फुल फॉर्म है आपका इंसुलेटेड गेट फील्ड इफेक्ट ट्रांजिस्टर, एंड MOSFET का फुल फॉर्म भी हमने देखा मेटल ऑक्साइड सेमीकंडक्टर फील्ड इफेक्ट ट्रांजिस्टर। दोनों ही जो हैं वो वोल्टेज कंट्रोल डिवाइस होती हैं। नेक्स्ट टॉपिक इज द मोड्स ऑफ ऑपरेशन। Modes of operation of the MOSFET. The MOSFET work by electronically varying the width of the channel along with charge carrier flow. Charge carrier means electrons and holes. The charge carrier enter the channel at the source and exit by the drain. The width of the channel is controlled by the voltage on an electrode is called the gate, which is isolated between the source and drain. It is insulated from the channel near an externally thin layer of metal oxide. The metal oxide semiconductor, in short MOS, capacity present in the device is the main part. This is the diagram of MOSFET. आप देख सकते हैं मेटल ऑक्साइड जो है वो सोर्स और ड्रेन को सेपरेट करती है बाय यूजिंग गेट टर्मिनल। द MOSFET कैन फंक्शन इन टू वेज। दो तरीके से जो MOSFET है वो ऑपरेट हो सकता है, या दो तरीके से जो है MOSFET काम करता है। पहला वाला है डिप्लेशन मोड एंड सेकेंड वन इज एनहांसमेंट मोड। दिस इज अनदर डायग्राम ऑफ द मेटल ऑक्साइड सेमीकंडक्टर फील्ड इफेक्ट ट्रांजिस्टर। So first one is a depletion mode. When there is no voltage on the gate, the channel shows its maximum conductance, as the voltage on the gate is either positive or negative. The channel conductivity decreases. So this is called the depletion mode. For example, this is the diagram for depletion mode of the MOSFET, N-channel MOSFET as well as the P-channel MOSFET. This is the symbolic representation of the MOSFET. Second is enhancement mode. When there is no voltage on the gate, the device does not conduct. More is the voltage on the gate, the better the device can conduct. तो ये वाला जो मोड होता है इसको हम बोलते हैं एनहांसमेंट मोड, क्योंकि इसमें हम जैसे जैसे वोल्टेज गेट के क्रॉस बढ़ाते जाएंगे वैसे वैसे हमारा डिवाइस का कंडक्टेंस भी जो है वो बढ़ता जाएगा। फॉर एग्जाम्पल, दिस इज द डायग्राम, symbolic representation of N-channel and P-channel MOSFET. If the VG is increased, so the VDS also increase. The next topic is working principle of MOSFET. The aim of the MOSFET is to be able to control the voltage and current flow between the source and drain. MOSFET ऐसा होना चाहिए जो कि वोल्टेज और करंट फ्लो हो रहा है सोर्स और ड्रेन के बीच में उसको इजीली कंट्रोल कर पाए. इट वर्क्स ऑलमोस्ट एज अ स्विच. एक स्विच की तरह काम करता है जो MOSFET है. द वर्किंग ऑफ MOSFET डिपेंड अपॉन द MOS capacitor. MOS means metal oxide semiconductor capacitor. The MOS capacitor is the main part of the MOSFET. The semiconductor surface at the below oxide layer, which is located between source and drain terminal, it can be inverted from P-type to N-type by applying a positive or negative gate voltage respectively. When we apply the positive gate voltage, the holes present under the oxide layer with a repulsive force and holes are pushed downward with the substrate. The depletion region populated by bond negative charges which are associated with the acceptor atoms. The electronic or the electrons, each channel is formed. The positive voltage also attract electrons from the N source and drain them into the channel. Now, if a voltage is applied between the drain and source, the current flow freely between the source and drain, and the gate voltage control the electron in the channel. Instead of positive voltage, if we apply negative voltage, a whole channel will be formed under the oxide layer. This is a practical diagram of or working diagram of MOSFET. It has 4 terminals: source, gate, drain and body. You can see the depletion region in a diagram. The next is types of MOSFETs. So the field effect transistor, in short FET, is classified into 2 categories, or we can say the broadly classification is 2 categories. First one is a JFET and second one is a metal oxide semiconductor field effect transistor. The JFET is further classified into 2 categories, N channel and P channel. Metal oxide semiconductor FET is further classified into 2 categories, depletion mode and enhancement mode. And depletion mode again further classified into 2 categories, N channel and P channel MOSFET. Similarly, the enhancement mode is further classified into 2 categories, N channel and P channel. The symbolic representation of all these transistors shown in a diagram. The MOSFET is classified into 2 categories. First one is P channel MOSFET and second one is the N channel MOSFET. So first one is P channel metal oxide semiconductor field effect transistor, in short MOSFET. The P channel MOSFET has a P channel region between source and drain. It is a 4 terminal device such as gate, drain, source and body. The drain and source are heavily doped P plus region and the body or substrate is N-type. The flow of current is positively charged holes. When we apply the negative gate voltage, the electrons present under the oxide layer with are pushed downward into the substrate with a repulsive force. The depletion region populated by bond positive charge which are associated with the donor atoms. The negative gate voltage also attracts holes from P plus source and drain region into the channel region. So this is the block diagram for P-channel MOSFET, as well as second one is a symbolic representation of P-channel MOSFET. So first one is called the enhanced mode and second one is called the depletion mode. Next is a N-channel MOSFET. The N-channel MOSFET has a N-channel region between source and drain. It is a 4-terminal device such as gate, drain, source and body. This type of the MOSFET, the drain and source are heavily doped N plus region and substrate or body is P minus type. The current flow due to the negatively charged electrons. When we apply the positive gate voltage, the holes present under the oxide layer pushed downward into the substrate with a repulsive force. The depletion region is populated by the bond negative charges which are associated with the acceptor atoms. The electrons reaches channel is formed. The positive voltage also attracts electrons from the N plus source and drain region into the channel. Now, if a voltage is applied between the drain and source, the current flows freely between the source and drain, and the gate voltage controlled the electrons into the channel. Instead of positive voltage, if we apply negative voltage, a whole channel will be formed under the oxide layer. So the first diagram is for enhanced mode of N-channel MOSFET and second diagram represent the depletion mode of P-channel MOSFET. Next topic is MOSFET characteristics curve. So this is the output characteristics of the MOSFET. The minimum on state gate voltage required to ensure that the MOSFET remain on when carrying the selected drain current can be determined from the VI transfer curve above. When Vin is high or equal to VDD, the MOSFET Q point move to point A along the load line. तो ये जो कैरेक्टरिस्टिक्स हमने ड्रॉ किया है ये कैरेक्टरिस्टिक्स है हमारा ID और VDS के बीच में. ID is called the drain current and VDS is called the voltage across the drain and source. ड्रेन और सोर्स के बीच का जो वोल्टेज है वो हमने x एक्सिस पे लिया है और y एक्सिस पे हमने लिया हुआ है ID मीन्स ड्रेन करंट. इसके बीच में जो ये हमारा कर्व प्लॉट होता है इसको हम बोलते हैं द कैरेक्टरिस्टिक्स ऑफ द मॉसफेट। जो कैरेक्टरिस्टिक्स है उसको हमने रीजन में डिफाइन किया हुआ है, कट ऑफ रीजन एंड सैचुरेशन रीजन। तो एक एक करके हम इस रीजन को समझेंगे कि कट ऑफ रीजन क्या होता है और सैचुरेशन रीजन क्या होता है। The drain current ID increase to its maximum value due to a reduction in the channel resistance. ID become a constant value independent of VDD and is depend only on VGS. Therefore, the transistor behave like a closed switch, but the channel on resistance does not reduce fully to zero due to its RDS value, but get very small. Likewise, when Vin is low or reduced to zero, the MOSFET Q point move from point A to point B along the load line. The channel resistance is very high, so the transistor act like an open circuit and no current flow through the channel. So if the gate voltage of the MOSFET toggle between two values, high and low, the MOSFET will behave as a single pole, single throw SPST solid state switch, and this action is defined as cutoff region. Here, the operating condition of the transistor are zero input gate value, zero drain current ID, and the output voltage VDS is equal to VDD. Therefore, for an enhancement mode MOSFET, the conductive channel is closed and the device is switched off. Cutoff characteristics. So the input and gate are grounded, means 0 volt. This is the diagram for cutoff characteristics of MOSFET. The gate source voltage less than to the threshold voltage, means VGS is less than to VTH. The MOSFET is off or cut off region, या हम बोल सकते हैं कि जो MOSFET कट ऑफ रीजन में होता है वो ऑफ कंडीशन में होता है. नो ड्रेन करंट मीन्स ID इज इक्वल टू जीरो. इस कंडीशन में जो हमारा ड्रेन करंट है उसकी वैल्यू जीरो होती है और आउटपुट वोल्टेज V आउट इज इक्वल टू VDS इज इक्वल टू VDD इज इक्वल टू 1. आउटपुट वोल्टेज हमारा ड्रेन और सोर्स के बीच का वोल्टेज जो होता है उसके इक्वल और VDD के इक्वल होता है. MOSFET ऑपरेट एज एन ओपन स्विच और कट ऑफ रीजन में जो MOSFET एक्ट करता है एज अ ओपन स्विच की तरह काम करता है. तो ये हमारा कट ऑफ रीजन कहलाता है. Then we can define the cutoff region or off mode when using MOSFET as a switch as being gate voltage VGS is less than to VTH, thus ID is equal to 0, where ID is called the drain current. For a P-channel enhancement MOSFET, the gate potential must be more positive with respect to the source. So this is all about the cutoff region of the MOSFET. Second is a saturation region. In the saturation or linear region, the transistor will be biased so that the maximum amount of the gate voltage is applied to the device, which results in the channel resistance RDS on being as small as possible with maximum drain current flowing through the MOSFET switch. Therefore, for enhancement type MOSFET, the conductive channel is open and the device is switched on. So this is the diagram and the characteristics of saturation region. In this, the input and the gate are connected to VDD, gate source voltage is much greater than threshold voltage, means VGS is greater than to VTH. MOSFET is on in a saturation region. Maximum drain current flow ID is equal to VDD divided by RL. सिंपल ओम्स लॉ से हमने ये फॉर्मूला निकाला है, V is equal to IR, so I is equal to V upon R. तो इसमें हमारे पास I जो है वो ID है, V की जगह VDD है और R की जगह RL है. सो हमारा ID का फॉर्मूला हो जाएगा ID is equal to VDD divided by RL. VDS is equal to 0 वोल्ट. आइडियल सैचुरेशन जो होता है उसमें हमारा जो VDS है वो 0 वोल्ट होना चाहिए. मेन चैनल रेजिस्टेंस RDS is less than 0.1 ohm. Vout is equal to VDS is approximately equal to 0.2 volt due to the RDS. The MOSFET operate as a low resistance or as a closed switch. तो सैचुरेशन रीजन में जो है वो MOSFET कैसे काम करता है, एज अ क्लोज स्विच की तरह काम करता है. Then we can define the saturation region or on mode when using an E-MOSFET as a switch as gate source voltage VGS is greater than to VTH. Thus, the drain current ID is equal to maximum. For a P-channel enhancement MOSFET, the gate potential must be more negative with respect to the source. By applying a suitable device voltage to the gate of FET, the resistance of the drain source channel RDS can be varied from an off resistance of many hundreds of kilo ohms, effectively an open circuit, to an on resistance of less than 1 ohm, effectively acting as a short circuit. When using the MOSFET as a switch, we can drive the MOSFET to turn on faster or slower, or pass high or low current. This ability to turn the power MOSFET on and off allow the device to be used as a very efficient switch with switching speeds much faster than the standard bipolar junction transistor. The next is a MOSFET using as a switch. So, an example of using the MOSFET as a switch. So, this is the circuit diagram. In this diagram, we can on and off the lamp by using the N-channel MOSFET. इस सर्किट डायग्राम में हम क्या करने वाले हैं, ये सर्किट डायग्राम हमने बनाया है, इसमें हम एक लैंप है उसको ऑन एंड ऑफ करेंगे by using the N-channel MOSFET. So in this circuit arrangement, an enhancement mode N-channel MOSFET is being used to switch a simple lamp on and off. So this is the circuit diagram. The gate input voltage VGS is taken to an approximate positive value label to turn the device and thereof the lamp load either on. जब VGS की हम VGS जो हमारा वोल्टेज अक्रॉस गेट एज सोर्स, गेट और सोर्स के बीच का जब वोल्टेज हम पॉजिटिव वैल्यू में लेंगे तो हमारा जो लैंप है वो ऑन होगा, और जब हम VGS की वैल्यू को 0 लेंगे तो जो लैंप है वो ऑफ होगा. If the resistive load of the lamp was to be replaced by an inductive load such as a coil, solenoid or relay, a flywheel diode would be required in parallel with the load to protect the MOSFET for any self-generated back EMF. तो अगर हम रेजिस्टिव लोड की जगह इंडक्टिव लोड लेंगे, क्योंकि हमारा बल्ब जो होता है वो रेजिस्टिव लोड होता है, इसकी जगह अगर हम इंडक्टिव लोड लेंगे तो एक हमें फ्लाईव्हील डायोड है वो पैरेलल में कनेक्ट करना पड़ेगा MOSFET को प्रोटेक्ट करने के लिए. Above show a very simple circuit for switching a resistive load such as a lamp or LED, but when using power MOSFETs to switch either the inductive or capacitive load, some form of protection is required to prevent the MOSFET device from becoming damaged. Driving an inductive load has the opposite effect from driving a capacitive load. For example, a capacitor without an electrical charge is a short circuit, resulting in high inrush of current, and when we remove the voltage from an inductive load, we have a large reverse voltage builds up as the magnetic field collapses, resulting in an induced EMF in the winding of the inductor. So this is all about the MOSFET, and finally the reference of this presentation. So these are the references. Anybody have any doubt regarding this presentation? So please ask me, and thanks for watching this video.